3D printed plastics are amazing, but how are they affected under intense sunlight and weathering effects? One of the longest running projects we've been working on at the System Health Lab has been measuring and quantifying the effects of UV on 3D printed samples. In order to understand how much UV these 3D printed samples are actually being exposed to, we've devised a system to data log and wirelessly transmit UV data from this device here over to the cloud. Since we're based up here up on the engineering building roof at UWA, we need a way to ensure that it'll survive the outdoor weathering effects such as dust, dirt and corrosion, and we also needed a way to power it safely and make sure it runs smoothly. One of the limitations of this device is that we're quite vulnerable to IT outages. So in the past, we've lost quite a bit of data. We've overcome this now by adding a new router and changing the system setup. After these improvements, we've seen an almost 100% uptime in the transmission of our UV dataset. The 3D printed plastics degradation project is a prime example of how the System Health Lab enables students from different disciplines to work together on a single project. As an electrical engineering student, I worked on the Wi-Fi enabled UV data logger project, whilst two mechanical engineering students in the past, Shrenna and Zach, put this data into their theses on 3D printed plastics. And in the future, the reins will be taken over by Yassine. The UV degradation project highlighted a few key features about the System Health Lab. Number one, that we're a continuously evolving and collaborative workplace. Number two, that students from different disciplines can come together and work on a shared project. And number three, that we're innovating in reliability to make real-world solutions for real-world problems.